Okay, so what is the scope? Well, in this tutorial, we are going to be basically understanding how to approach input validation. And this is useful for any input validation library. So while the topic might be more constrained in a way to Joi.js, which is a JavaScript input validation library, a lot of the topics that I'm going to be bringing up and just touching upon can be abstracted to essentially any programming language or input validation library. So just kind of learning how to think about input validation is essentially the key point here. And also, we are going to be learning how to create JSON validation schemas within Joi.js. So, what is Joi? Well, it is a JavaScript input validation library. And basically, you create JSON schemas that validate JSON payloads entering an API or leaving a browser. Okay, so you got it. So essentially, it's cool because you can share one JSON schema between an API and a browser. Obviously, you would not just want to stay with just only do your input validation on the browser, right? Because that could easily be bypassed by a malicious individual. Okay, but from a user experience perspective, having schema validation or just any kind of user input validation in the browser is obviously a huge win. So why leverage Joi? Well, Joi provides some very granular whitelisting functionality. And with whitelisting, basically you're just defining what you will accept from the user, and everything else is denied by default. Okay. And types of input validation. So here's just kind of a question for you to think about, and you can pause the video after I pose the question. And yeah, and if you need a little help, I'm going to give some hints after a brief pause. So anyhow, in general, when user input is sent to the API, what types of input validation should we perform? Okay. Now, there's a couple of different types. So I'm going to go ahead and proceed with one hint. So think about the different types of coding errors that occur, okay? And think about potentially how those can relate to types of validation that we should perform, okay? So think about two primary ways. Think about the two primary coding errors that there are, okay, when you're developing code. And then think about how those could potentially map to items that you need to validate from user input, just general categories of input that you would, or of things that you need to validate. Okay, so for me, I really see two primary checks that need to occur when untrusted input, in other words, user input, comes to the API. And here's the thing, and I'm just saying two main overarching types. I'm sure there are other types as well, but I'm just trying to go for generics here. But anyhow, if these checks are not completed, the server might act in unintended ways, and that's just because code might not be expecting input to come in a certain format or kind of in another context, just in general. Okay, so types of input validation checks. So I kind of think of this as a quote unquote like syntactic check of input that's coming into the API. So in other words, you are checking the overarching form of the input. Now, an example is the input a string with length X? Okay, so you can constrain a string to be a certain length within Joi. Now, here is the interesting thing, okay? So when you're going ahead and doing your input validation, you want to be as granular as possible. And you might be like, why would I want to constrain, excuse me, why would I want to constrain the length of a string? And because you might be like, I can't conceive of any attacks that could, leverage that. Well, the item is, for example, regular expression denial of service or REDOS. Basically, what happens is sometimes long strings, okay, that are fed into a regular expression that is vulnerable to something called catastrophic backtracking can actually go ahead and hang or just basically just crash the server, okay? Basically a denial of service attack. So I know that there was a point, even when I was a developer, that I did not know about regular expression denial of service attacks. Okay. So there are just, I guess the assumption is that there are always are attacks that you cannot conceive in a given moment. So that's why you just want to make your input validations just as granular as possible, even if it doesn't appear readily obvious why you are making it this granular. Okay. So here's the thing, the input validation checks, okay, or excuse me, the syntactic quote unquote checks, that is the huge use case for Joy. Joy rocks it, okay, when it comes to this, okay? But there's also more of a semantic check, okay? And these are more logic checks, okay? And I'm just putting it in quotes here just because it's not it's not a direct 100% mapping, but just kind of just a general idea of just how to think of input validation. I think it's easier to remember if you think of it in terms of syntactic and semantic, okay? Because those kind of map just to how to think about errors in code. So anyhow, so semantic checks, these are more logic checks, okay? And now an example of this would be, does the user have appropriate permissions to do a certain action? Now, this is not what Joy is intended for, okay? So that is something that could be a big topic for another tutorial, but it's not within the scope of this tutorial or within Joy. Okay, so Joy advantages. So here's the thing. If you aren't leveraging JavaScript or Node.js, look for these features in basically a library, an input validation library. So the potential to share a JSON schema between the front end and back end is awesome, and that's a huge advantage to Joy. So yeah, it's big. So if you want to check out the front end piece, check out this link, and the back end obviously is here as well. And also yeah, I'm going to basically be providing a Joy schema, and if you want to run that locally, you just make sure you have the latest version of Node installed, and also install Joy through the installation instructions. But basically, I mean, this installing Joy and running all this stuff locally isn't basically a requirement for this tutorial. A lot of this you can just see through, your eyes, right? But anyhow, if you want to do it, there are the installation instructions. Oh, excuse me. So, and the other thing about Joy and a distinct advantage is basically it allows you or a developer to validate input at the entry point, basically into the server. Now, this is much safer than doing your validation logic, say, within the database library. So, for example, there are database validation within a database library. You can define certain validation mechanisms. So before you go ahead and persist items to the database, it'll be run through essentially a schema and be like, hey, is this kosher to go into the database? Obviously, that is an amazing item to have. Okay, I am just saying my argument is if you are on a super crazy time crunch and you I would prefer, or I would make the argument that you should validate at the entry point rather than at the data layer. Okay, but if you have enough time to do both, obviously there are tremendous security wins from doing both. Okay. So, okay, and also another Joy advantage and something that you want to be looking for, just an overarching data, excuse me, input validation library is really, is there any middleware that can wrap the input validation library? So it would just make it very easy to integrate into your API. Now, Joy has this, and it's called Celebrate. This individual went ahead and created it, and it's awesome. So it's a Joy validation middleware for express.js. Okay. And okay, so let's kind of start thinking about Joi schemas, and that's basically the brain of Joi. Now, Joi leverages schemas to define validations. Okay. And within a schema, you define types and constraints. Okay, so this is one line in a Joi schema, and this would be validating the root username field within a JSON object that is being posted to an API, for instance. Now, okay, what about this joy.string? Now, this is what this is. This is a type example, okay? And this generates a schema object that matches a string data type, okay? So this username, it has to be a string. Now, here's the other item that's very important is joy.string inherits from joy.any. And joy.any generates a schema object that matches any data type, okay? But it also exposes some other methods. Joy.any exposes some other methods that we will see in a slide or two. Now, okay, so what is an example of a constraint? Well, alphanumeric, that's a constraint, min, I think you get the idea. But each constraint, here's the key takeaway. Each constraint returns a new schema object. So, which is awesome, given that method, that basically means that method chaining is available. So that's how we can do alphanumeric, min, max, etc. But what about this? This is a huge kind of gotcha with Joi, okay? Required, and we're about to learn about that here. So here's the thing. Without this required, this whole thing is optional, okay? So username would be optional. So make sure that if you're defining basically a validation and you need it to be there, make sure that that required is in there. It's very important. Now, what are some additional Joi types? Well, there is well, actually, okay, so we already saw this. So essentially, I'm just saying, besides string, what else is there? And there is array, Boolean. These are just some of the big ones. Binary, which is great. Date, as what we will see very soon, that you can actually validate JavaScript dates. Func, number, and object. Okay. Now, here's kind of a question, and basically I'm going to be showing you a Joi schema coming up, but also it can be bypassed in a few ways. So, or in one way in particular. So this will be kind of an interesting exercise. So anyhow, while viewing the following schema, object, and payload on the next slide, think about how it could be exploited or bypassed. And further assumptions is that the JSON payload is submitted to the API. Okay, you'll see this payload in the next slide. Okay, so that payload is submitted to the API, and Joi does not throw a validation error. In other words, the JSON payload that is submitted is Joi thinks is completely fine. Okay, and it is right to think that it's completely fine. Okay, now after that, the JSON is directly saved to the database. Okay, and what I mean here is that the payload key value pairs are directly mapped to database fields and values. So in other words, it could update given fields or values in the database. Okay, now if you wanted to kind of check this out, I suggest you just kind of click on this link and it will open you up. It might, yeah, it's basically going to open you up right here into the schema. But I'll also kind of show it in the next slides. Oops, sorry about this. All right, here we go. So here is the schema. So here we go ahead and require Joi. Okay. Now, and just remember, I'm going to be basically I'm hoping my goal here is to show you a bunch of use cases in Joy that would be very or hopefully advantageous for a developer in their common day-to-day workflow. So I'm going to show you these examples like validating a username and password, etc. But also think about how any one of these could be bypassed potentially. Okay. So yeah, so just something to throw out there. Okay, so here we are defining a schema. All right, so basically we are expecting a JSON object. So that's why we define Joi.object, and we go ahead and start whitelisting some keys that can come across in that JSON payload. So we have a username. So basically we're defining a string, making sure it's alphanumeric, and we kind of saw some of this in the previous slide, so I'm not going to harp on it. Here's another kind of cool item that you can do with Joy is really defining password complexity requirements through a regular expression. Now, okay, this regular expression is not sufficient for a truly complex, secure password. Um, but you can easily find those online. I'm also going to be providing those at the end of this tutorial series within kind of the notes. So of some other ideas of regular expressions that are sufficiently complex. But I'm kind of keeping it simple here just so if you want to play around with the schema locally, you can easily do so. So, okay, so we are defining up some password complexity requirements through a regular expression, okay? And we are requiring it. Now, here's kind of a cool thing. We can also force passwords to match, okay? So we're going ahead, we're inheriting from joy.any. There's some cool methods that exposes. One is equal. So it's basically saying make sure password confirmation, whatever is passed here, at whatever is the value of password confirmation, needs to directly equal the password, which is great. You can go ahead and accept different Joi types. So here we have an optional unconstrained string or number. Okay, so when you want to accept different items, you can pass it within an array syntax. And we go ahead, get the birth year. Okay, you can also validate email addresses. Okay, now, obviously, you want to be, I mean, someone could obviously submit a fake or spoofed email address here, but you can validate the form of an email and make sure it comes from a specific, domain. And also you can set booleans. And here's kind of the other cool thing is say if you're accepting different tokens, you can actually, Joi has a GUID method. So you can make sure that a given token is validated over UUID v4, which is pretty sweet. Now, if you want to accept multiple types of strings, this is kind of another way of doing that, okay? And here is the Joi date validation. So a JavaScript timestamp it validates. And also roles would basically just would be an object, okay? And go ahead and basically pass in no keys there. Okay, so here's another thing. Is this dot with at the end? This says if there is an email, a user must submit basically a marketing opt-out key. So this is kind of cool because you can do with, you can do without, so you can just do kind of matching logic as well. So if one field in the JSON is there, another field must be there additionally. So yeah, pretty cool. So if we go through, here is a little, we're validating right here, just doing the joy.validate. This is one way of doing schema validations within Joi. So we pass in basically the payload from the user right here. So Ronald McDonald signing up. Hopefully I don't get sued by McDonald's over this, over some trademark infringement. But anyhow, so he's got his big Ron right here. And anyhow, that goes through. And then we also pass in the schema that we defined up here. Okay. So that goes through and basically if there is if result dot error is equal to null, then the payload is valid. Okay, so go through. and the validation error is null. So that means there is no validation error and everything is fine. So here's the thing. So kind of think about this schema that we had up here. Think of any unintended items that could be passed in here that could exploit, um, could potentially exploit some backend logic given the assumptions that I brought up a couple slides before. Now, we're going to be kind of going into the exploit kind of potential vector of attack for this schema in the next tutorial. But for now, I'm going to pause and I'll see you then. So thanks for joining me.